Okay, same drill as normal. We need to get rid of a variable in two of the equations. So the easy one to get rid of, it looks like, is going to be x. So I'm going to take this guy and multiply him by 2, which gives me 2x plus 2y minus 4z equals 6. And then I'm going to just put this guy straight across. 2x minus 3y plus z equals negative 7. If I add these together, I end up getting those guys to go away. Negative y minus 3z equals negative 1. All right? So now what I'm going to do is I'm going to multiply this guy by 2. And then I'm going to bring this guy straight down. So this guy multiplied by 2 is going to be 2x plus 4y plus 2z equals 8. And bring this one straight down, you get negative 2x minus 3y plus z equals negative 7. This will go away. This becomes y. This one becomes 3z. And then 8 minus 7 is going to be 1. Now, I am going to just add these guys together. So I'm going to take this guy, bring him straight down. Negative y minus 3z equals negative 1. So, if I add these together, I end up getting, 0 equals 0. Now, if we had two equations and two unknowns, we know that that is many solutions. And the many solutions would be one of the equations. Now, with this one, it's a little more difficult because we want to state the answer in linear equations and not have 3 variables. So that's why it was a little more difficult in class to do this one. So, our answer is going to look in the form of, let me write that a little better. Is going to be in the form of all x, y, z's, all these points. And one of the criteria, if you solve this guy for y, you end up getting y equals negative 3z plus 1. Okay, now, that can't be the only criteria because what we need to do is we need to find another function that we can plug z into to get my x. So what I'm going to do is I'm going to pick any z, and if I plug in z, I'm going to get a y, and then I need to find something that'll give me an x. So what I need to do is I need to find something else that I can use. So I have y and z. I probably want another function of z that has x in it, which means we need to get rid of y on one of these guys. So if you don't mind, I'm going to erase all this work. And I'm going to start over, but this time I'm in the mind frame of getting rid of y this time. So in order to get rid of y here, I need to multiply him by 3. So I'm going to multiply by 3. So I get 3x plus 3y minus 6z, and that equals 9. And then I'm going to use this guy and just bring him straight across. Negative 2x minus 3y plus z equals negative 7. If you add these together, you end up getting x. That goes away. This becomes a negative 5z equals, now this becomes a 2. So if I add z over, I end up getting x equals 5z plus 2. So that is the other criterion that we're going to need. X equals 5z plus 2. Now, what we're going to do is we're going to make z just any real number. So what this means, what this says, is that I can pick any number I want to be my z. And then after I pick z, I have to plug it into here and here to get my x and my y. So let's have an example. Let's say 1, I want to pick z to be 1. This is just an example. So if I pick z to be 1, then we end up getting 5 plus 2, which means x is going to be 5, 6, 7. And then y is going to be negative 3 plus 1, which is negative 2. So one of my answers is going to be 7, negative 2, 1. Now this video is getting a little long, so I'm not going to do it, but if you plug these three numbers, they will work for all three of these equations. So that's the main point, is you pick a z, plug z into here to get a y, plug z into here to get an x, and then you can have a point that works. So pretty much no matter what you pick for z, it will be a point that will satisfy these three equations.